Hi guys, welcome to today's tutorial. Well, today we'll be treating on probability. Alright, I would like you to get your writing materials ready with your calculators standby. We'll be right back.
To enjoy mathematics, you need to know the basics. We at Mathematics Simplified are here to make it easy. Ensure your notification button is on, like, subscribe, and share with friends.
Welcome back. Today, like I said, we'll be looking at probability. But first off, we need to understand the term probability. What is probability? Now, probability is the likelihood of an event to occur. Okay? The chances that something will happen will tell you the probability of that event. Okay? Now, when we say the probability that rain will fall is 50%, that means there are 50% chances of rain falling and 50% chances of rain not falling. The probability that Okon will pass his exams is just 3/10. That means Okon has more chances to fail the exam, which is 7/10, than to pass the exam, which is 3/10. So today we'll be looking at the context of probability, the tricks about probability, and how to answer questions on them. So follow me closely so that you won't miss out of this. Don't forget to like and subscribe to our channel to get more updates. Probability is the likelihood of an event to occur. Okay? The chances that an event will occur is what we look at as probability. Now, what's an event? An event is referred to as the outcome of a trial. Alright? The outcome of a trial is referred to as your event. What's a trial? A trial is an attempt. The attempt to take in an experiment is referred to as a trial. For example, when you're tossing your die, your Ludo die or a coin, okay, the number of times you toss them, okay, are referred to as your trials, because for each toss you toss, you're either getting a head and a tail. If it's a die, a coin, you're either getting a head or a tail. So for each of those tosses you're tossing is referred to as your trial. Alright, an experiment is a process by which we generate an observation or a measurement. Okay, experiment is a process by which we generate observations or a measurement. Now, sample space is a set of all the possible outcomes in an experiment. Your sample space is a set of all possible outcomes in an experiment and is denoted by S. Now, for example, if you're asking for a sample space for a coin, okay, your sample space for a coin, okay, will be a head and a tail, because these are just the two possible outcomes you could have. Now, sample space for a die will become 1, 2, 3, 4, 5, and 6. That's the sample space for a die. Now, each possible result from a trial is referred to as an outcome. Each possible result from a trial is referred to as an outcome. Okay? Now, when we talk about equally likely events, now there are two or more events that have equal chances to occur. Equally likely events are two or more events that have the equal chances to occur. Now, when we talk about equiprobable events are events that have equal probability, like your head and tossing a fair coin, alright, which gives you a head and a tail. The probability of a head occurring is half. The probability of a tail occurring is also half. So they have equal chances of occurring. Now, a fair die also has equal chances of getting any of those numbers. Now, each of them, when you roll a third die, you must get one of these numbers. Okay, that's why it's called an equiprobable event. Alright, now an impossible event is an event that cannot occur. Example is unrolling to get a 7 from a single die. You roll a single die, it's not possible to get a 7 or a 9 or a 10. So for this impossible event, its probability of impossible events is always 0 because it can't occur. Okay, the probability of it occurring is 0 because it can't occur. That's why it's called an impossible event. You are sure that it can't occur. You can't throw your coin up to get a head and the tail at once. It's an impossible event. Alright? So it's either you get a head or a tail. You can't roll a single die to get a 10. It's impossible. So the probability of an impossible event to occur is 0. Now, when I talk about certain events are events that you are sure they are going to occur. Certain events are events that you are sure they are going to occur, and the probability of your certain events are always equal to 1. The probability that events are sure that they are going to occur are always equal to 1. Example, the probability that when you toss a coin, you will get either a head or a tail. Now, probability of a head, we have seen it to be 1/2. And probability of a tail, we have seen it to be 1/2. So if we add these two together, we are getting 1. That is why it is a certain event that when we toss our coin, we are going to get either a head or a tail. So it is certain that one of these must occur. Alright, having said that, let's look at some possible probability laws that will help us in the study of probability. Laws of probability. Now, our first law there says that first we need to understand that probability can never be negative. You can't have a negative answer in probability. Once you are calculating your probability and you are getting a negative answer, please know that you are wrong. Know that you are wrong. Once you're getting a negative answer, your probability can never be negative. Now, 2, your probability of any event can never be greater than 1. Your probability of any event can never be greater than 1. So once you're calculating and your answer is giving you greater than 1, you are wrong. Recalculate, check your statistics again, and ensure that your probability cannot be greater than 1. Thirdly, that your probability of an impossible event is 0. We've said that before, that the probability of an impossible event is 0. Okay, that you're certain that this event cannot occur. Like for example, getting a 9 from a single die. You are sure that it can't occur. It is 0. Now, when you're sure that an event will occur, okay, like when you toss a coin, you either get a head or a tail. You are sure that one of them would occur. Then that is your probability is 1. Now, the sum of probabilities of all possible outcome is equal to 1. What does this mean? We look at our possible outcome for a single die. Our outcome for die, okay, we have a sample space of 1, 2, 3, 4, 5, 6. And we've established the fact that for this to occur, we are having probability of 1 plus probability of 2 plus probability of getting a 3 plus probability of 4 plus probability of 5 plus probability of 6. all this is saying is that all these possible outcomes are going to be equal to 1. The probability of all these outcomes occurring are going to be equal to 1. Let's not forget that in solving probability, our probability equals to our events, number of events occurring, all over our number of sample space. Okay? Number of events occurring over number of sample space. Or otherwise put, in simple terms, possible required outcome all over total outcome. Okay? Our possible required outcome over total outcome. Now, let's look at this, taking this as an example. If we say we are looking for the probability of getting 1, our probability of getting 1 is 1 over 6, plus probability of getting 2, 1 over 6, plus probability of getting 3, 1 over 6. Since this is an equiprobable sample space, all of them will be 1 over 6. And if we should add all this up, our LCM here will be what? 6. Okay? So 1 plus 1 plus 1 plus 1 plus 1 plus 1 will give us 6. 6 over 6 will give us 1, which proves that for every possible probability, the sum of all their possible outcomes must always be equal to 1. Now, we will look at some examples on how to apply probability. A ball is drawn at random from a bag containing 3 red and 2 blue balls. Find the probability that the ball drawn, 1 is not red, is red, and 2 not red. Now, in solving this, what we are going to do is, first of all, we have 3 red balls and 2 blue balls. Alright, so our total number of balls in the bag will be 5 balls. Alright, so our total number of balls will be 5 balls. Now, probability that is red, probability of having a red ball will become the number of red balls possible. Remember that our probability, okay, of an event to occur is number of events all over number of sample space, okay, or possible outcome over total outcome, or we have it as possible outcome all over total outcome. Now, the question is, what's our possible outcome of picking a red ball? How many red balls are there will determine our possible outcome. So, the possible outcome here will become 3 over the total outcome, 5. So, the probability of picking a red ball will be 3 over 5. Now, what is the probability of not picking a red ball? Probability that is not red. Now, probability of not red can be found in 2 ways. Alright? Either we do probability of not red as, now, let's look at it this way. Probability of red, we have it as 3 over 5. And probability of not red will become, probability of red is 3 over 5. Probability of not red will become 1 minus 3 over 5, which will give us 2 over 5. And probability of blue, okay, we weren't asked, but we will solve it, is 2 over 5. And probability of not blue will become 1 minus 2 over 5, which is 3 over 5. Now, this is it. Since probability of blue, probability of red, plus probability of not red equals to 1. Okay? So probability of not red will become 1 minus probability of red. That's how we arrived at this. Okay? So bearing in mind, we should always bear in mind that our probability of its occurring, its success and its failure are always equal to 1.
To enjoy mathematics, you need to know the basics. We at Mathematics Simplified are here to make it easy. Ensure your notification button is on, like, subscribe and share with friends.
What is the probability of obtaining a 1, B, a 2, a 3, C, a 6, D, at least 3, E, at most 4, F, an even number, G, an odd number, H, a prime number? Now, this table was given to us from an experiment conducted that we should find the probability of obtaining this. Now, the first thing to do is to find out what is your total frequency. Okay? What is the total of all these numbers? Alright, that will give you your total outcome. If we have 18 plus 14 plus 20 plus 16 plus 15 plus 17, we are having 100. So our total here, our total outcome will be 100. Okay, now it says, what is the probabilities? Solution. Now for A, what is the probability of obtaining a 1? Now, what is our possible outcome? What is our possible outcome of getting a 1? 18. So this becomes 18 all over, what's our total? 100. 100. Alright? Now, another short thing you should always remember is to break down your probability to its lowest term. Break it down to its lowest term. 2 can go into 18 to give us 9, and 2 can go into 100 to give us 50. So, nothing, 2 cannot go, and 3 cannot go into this 2. So we leave it as 9 over 50. Now, for the B, it says, what is the probability of obtaining a 3? Now, probability of obtaining a 3 will be 20 all over 100. So we break it down to its lowest and we'll get 1 over 5. Alright, now our next question, C, says the probability of obtaining a 6. Probability of obtaining a 6, we have it as 17. Probability of obtaining a 6, we have it as 17 over 100. Now we cannot break it down, so we leave it as 17 over 100. Now if we talk about D, at least 3. Okay? When we say at least 3, the least number we should get means we should be having 3. We can have more than 3, but not less than 3. We can get more than 3, but not less than 3. So we'll be looking at probability of getting a 3, plus probability of getting a 4, plus probability of getting a 5, plus probability of getting a 6. So we'll be having our probability of getting a 3, this will become 20 plus 16 plus 15 plus 17 all over our total 100. Okay, so if we should add this up, this will give us 20 plus 16 plus 15 plus 17. That will give us 68 over 100. Okay, we break this down. 2 into 68 will give us 34 all over 50. So 2 can still go into 34. 2 into 34 will give us 17 over 25. So that's our answer for D. So for E, when it says at most, probability of at most 4. Alright? When it says at most 4, at most means that the highest number you should get would be 4. Okay? Now note the difference between at least and at most. Now for at least, the lowest number should be 3. While for at most, the highest number should be 4. That means you can get below, but not more than 4. So at most 4, we'll be having 18 probability of 1 plus probability of 2 plus probability of 3 and plus probability of 4. Okay? Now this is all over 100. Now this will give us 18. This plus this is 30. 30 plus 20, 50. 50 plus this will give us 68 over 100, which is going to give us 17 over 25. Now, let's look at the next one. It says, our next question says, an even number, F. Probability of even number. Okay? Now, what are even numbers? Even numbers are numbers that can easily be divided by 2 without a remainder. Example, 2, 4, 6. Okay? For this, so we'll be having the probability of 2, which is 14, plus the probability of 4, which is 16, plus the probability of 6, which is 17. All over what? Our total, 100. This is 30. 30 plus 17 will give us 47 over 100. We cannot break this down, so it remains like that. Now our G, which talks about probability of odd numbers. Now, odd numbers are numbers that cannot be divided by 2. Okay, if they're divided by 2, they have a remainder. So we have our 1, we have our 3, we have our 5. So this will become 18 plus 20 plus 15 all over 100, which is going to give us 18 plus, this is 10, 30, 40, 48, 48 plus 5 will give us a 53. So we're having 53 over 100. Now, okay, it can't be broken down, so we'll leave it in that form. Now, to our last question, H, it says probability of prime numbers. Now, what are prime numbers? Prime numbers are numbers that can be divided by 1 and itself. Okay? Prime numbers are numbers that can only be divided by 1 and itself. That is to say, prime numbers have just 2 factors. Most people, I've seen most people include 1 as prime numbers, as a prime number. Please, 1 isn't a prime number. Take note. 1 isn't a prime number. So our prime number will start from 2, 3, and 5. These are our 3 prime numbers. 2, 3, and 5. So we'll be looking at probability of 2 plus probability of 3 plus probability of 5, which will give us 20, 30, 40, 49 over 100. Alright, I think we've answered all. So please, if you've watched up to this moment, like, subscribe, and click on the notification button to get more updates. And don't forget to share our channel with your friends. A basket contains 60 balls, some red, some green, and some blue. If a ball is selected at random from the basket, the probability of getting a red ball is 1 over 4. The probability of getting a blue ball is 1 over 12. Now, to the question, how many green balls are in the basket? Alright, now we know that probability equals to our possible outcome over total outcome. Now, but in this case, we've been given the probability of a blue ball. Probability of red is 1 over 4. Probability of blue is 1 over 12. Then probability of green, we do not know. Okay, let's call this X. Okay, now we know that from our law that the probability of all these are equal to 1. So if we have probability of red plus probability of blue plus probability of green all equal to 1. Okay, now our probability of green will become 1 minus probability of red plus probability of blue. Okay, now what's our probability of red plus probability of blue? If we have 1 over 4 plus 1 over 12, our LCM will be 12. Okay, our LCM will be 12. 4 into 12, 3. 3 times 1, 3. Plus 12 times 1, and 12 into 12, 1. 1 times 1, 1. So this will give us 4 over 12, which is 1 over 3. Okay, so if our probability is 1 over 3 for these two, then we can now say that our probability of green will become 1 minus 1 over 3. If we have 1 minus 1 over 3, 1 minus 1 over 3, our LCM will be 3. 1 into 3, 3. 3 times 1, 3. Minus 3 into 3, 1. 1 times 1, 1. Which will give us 2 over 3. So our answer will become 2 over 3. That's the probability of green. But now, they are asking us how many green balls are in the basket. How many green balls are in the basket? Now let's look at for red balls. How many red balls we have will be for 1 over 4 times total balls we have 60 over 1. Okay, that's to find the number of balls there. For blue ball will become 1 over 12 times 60 over 1. Then for green balls it will become 2 over 3 times 60 over 1. Okay, so in it all, we are going to have 4 into 60 will give us 15. So 15 times 1 will become 15 balls. So there are 15 red balls. 12 into 60 will give us 5. And there are 5 blue balls. 3 into 60 will give us 20. 20 times 2, 40 green balls. So if we add this up, we can see we are having 60. 15 plus 5, 20. 20 plus 40, 60 balls. So our green balls will be 40 balls. Alright guys, we've come to the end of today's tutorial. Alright, please do not forget to like, subscribe, and click on your notification button to get more updates. If there be any comments or questions on regarding what we've done so far, do not forget to put them down at the comment section and we'll be sure to reply each and every one of them. Alright, see you guys next time.